Next we have what can be called the midpoint sum. All right, here the rectangle is defined by the height of the function at the midpoint of the rectangle, of the width of the rectangle. All right, so this notation actually makes it look more complicated than it really is. But if we build our 4 partitions, so again, our rectangles go from 0 to 0.5 to 1 to 1.5 to 2, and these can change, but these are the same rectangles that we built last time, so I'm going to use these again. And now our rectangle extends up until the midpoint of our rectangle touches the function. The midpoint of the top edge of the rectangle touches our function, and same is true here, same is true here, same is true here. So you can see that the x values where these heights are defined are not 0 or 0.5, but 0.25, 0.75, 1.25, and 1.75. So those are the x values in this case which define our height. So f of 0.25 defines the height of our first rectangle, f of 0.75 defines the height of our second, and so on. And so when we do that and make and add up those values, we get 7.2813. All right, so that's our midpoint sum. What I want to show to you is that the midpoint sum is not just the average of the upper and lower. So it is not just the average of the two. All right, so be careful. That's a common misconception. The midpoint will give us a better estimate. It's going to be closer to the true value of the area underneath this parabola between x equals 0 and x equals 2. But it is not simply the average of the upper and lower. All right, it's a unique value.